Hello there, I'm your teacher Barbara Rademacher here in the Math Playland. Today we're going to review linear functions. Finding the equations of straight lines, talking about slope. In the first part, that's what we're going to do. Talk about slope, talk about equations of lines. But in the second part, we're going to be talking about inequalities and applications. But right now, let's get started on the first part. Here are your homework problems, worked by me. The best way to do this, of course, is actually to write while I'm talking. But I also realize that the neatest way to do it, so that people can actually read my work, is if I write it first neatly and then go back over what I've done with you. So that's what I'm going to do. All right, so we're going to start off talking about straight lines. So let me reintroduce you to y equals mx plus b, where m is the slope of the line. It's a number. It's the number in front of x when you have this line in y equals form. The y-intercept is 0b. Whatever the b number is, we'll have parentheses, a 0, a comma, and then the b number, and that is the y-intercept. All right, what we're being asked to do in this first problem is to look at this equation of a straight line in standard form and figure out what the slope and the y-intercept are. Notice this is not in y equals mx plus b form. It's in a form called standard form. What we have to do is translate to slope-intercept form, which is the official name of y equals mx plus b. So your first step in doing this is to solve for the y term. Get the y term, negative 8y, all by itself. To do this, I'm going to subtract 7x from both sides of the equation. That's because 7x minus 7x is 0, and that will leave me with negative 8y, which is what I want right now. And notice here in y equals mx plus b, the x term is always in front. So I changed the minus 7x to negative 7x. They're really the same thing. And so I have, after I say 7x minus 7x is 0, I have negative 8y equals negative 7x plus 9. Then to get y by itself, because that's what I need, to get y by itself, I divide by negative 8 the number in front of y, which we call the coefficient. I divide by negative 8, I divide every number by negative 8. Negative 7 over negative 8 is positive 7/8. Of course, the negative 8's cancel out on the left. And over on the right, I'll have positive 9 over negative 8. Positive divided by negative is negative. So our answer will be y equals negative 7/8 x minus 9/8. Correction, that's not the answer to the problem. That is the translation of this standard form linear function over to slope-intercept form. Now, how do I know what the slope and the y-intercept are? The number in front of x, when I have the equation in y equals form, the number in front of x is the slope, so the slope is 7/8. and the number at the end is -9/8. Numbers and letters, variables, always take the sign in front of them. So our y-intercept is 0, comma, -9/8 in parentheses, because that's always the way you write a point. And the y-intercept is a point. Now the next problem is find the slope of the line containing this pair of points. This is one point with an x and a y coordinate, and this is one point with an x and a y coordinate. In order to differentiate them, I call this point x1, y1, and this point x2, y2. Then I use the formula for slope. y2 minus y1 over x2 minus x1. y2 is -7 minus y1 is -4 over x2 minus x1, 2 minus 7. Whenever you subtract a negative, that gives you a plus sign. So instead of -7 minus -4, I now have -7 plus 4, which is -3 in the numerator, and 2 minus 7 is -5, so we'll have -5 in the denominator. Negative divided by negative is positive, so our answer is 3/5. That is the slope, 3/5. Now the next problem is an application problem, a word problem. How do we find the pitch of this roof? Let's make this a little bigger so that you're sure to see it. The highest part of the roof is 0.7 feet high. And from that over to the edge is 9.9 feet. The vertical side of our triangle here is called the rise, and the horizontal side is called the run. Slope is rise over run. In fact, that's precisely what y2 minus y1 is, over x2 minus x1. y2 minus y1 is the rise, and x2 minus x1 is the run. I divide 0.7 by 9.9, and I get this run-on repeating decimal, 0.0707070707. Okay, and the way I show that is to put a straight line over the 0.7. Now pitch is given in percent, so I have to change this decimal to a percent. I do that by multiplying the decimal by 100%, or 100, which is what I did here, and it gave me 7.0707070707. The instructions say, I neglected to copy them, but the instructions say to round to the nearest percent. So our answer is that the pitch of the roof is 7%. Now in college algebra, as in life, as in business, the main use, one of the main uses of slope is to find how fast whatever you're measuring is changing, usually over time. That's what we have here. Find the rate of change, that means slope. Find the rate of change in luxury purchases in a certain country with respect to time in years. Here's what that means. On the vertical axis, usually called the y-axis, we have money in billions of dollars. The horizontal axis, which we usually call the x-axis, it is the time axis, that is time in years. 2010, 2011, 2012, 2013, and so on up to 2017. We're being asked to find the rate of change, that is the slope of this line. So I'm going to be using the formula m equals y2 minus y1 over x2 minus x1. That's the rate of change. I call this point x1, y1 because it's on the left, and this point x2, y2 because it's on the right. The world would not come to an end if you called this point x2, y2 and this point x2, x1, y1, as long as you were consistent. But the way I have it set up is this. y2 is 27.3, y1 is 8.5. So y2 minus y1. x2 is 2017, y2 is 2010. So 2017 minus 2010 is x2 minus x1. That gives us 18.8 over 7, which okay. First, I found out what 27 minus 3 minus 8.5 is, and that's 18.8. I could pretty well figure out what 2017 minus 2010 is. It's 7. So then I divided 18.8 by 7, and I got 2.685714286, and this decimal probably goes on forever. The instructions said to round to 2 decimal places. Well, I have a 6 and an 8. 6 is my first decimal place, 8 is my second decimal place. I have to look at the third decimal place, 5, to find out whether or not I should round 8 up to a 9. Because 5 is 5, any number that is 5, 6, 7, 8, or 9 will cause the decimal number to the immediate left of it to round up 1 unit. This 5 will cause the 8 to round up to a 9, and as a result, yes, I put the answer down here. As a result, the rate of change of luxury purchases per year in that particular country is $2.69 billion per year. Here are the instructions: type an integer or a decimal rounded to 2 decimal places as needed, and we needed it. So 5 caused the 8 to round up to a 9, which gave us the answer 2.69. With billions understood. We have another rate of change problem here. Now notice, I want you to look at something. Notice how this line is rising from left to right. That means that the slope is positive, which means your rate of change is increasing. When the line is dropping from left to right, that means your slope is negative, which means that the rate of change is decreasing. Find the rate of change. What we have is, all right, number of years in use and the value of a computer in hundreds of dollars. Okay, well, that must be a pretty expensive computer in the beginning. There are 6 units between each of these digits. 0 to 6 is 6, 6 to 12 is 6, and so on. So 24 to 30 is 6, and this point is halfway between 24 and 30, so that will be 3 points. 24 plus 3 is 27. So x1, y1, which is on the left, is going to be 0, 27. In math and in science, year 0 is in the beginning of the measurement. Then 3 years later, the value of the computer in hundreds of dollars is 18. That is 2,700 and 1,800. Like I said, it's a really expensive computer. But that doesn't matter. What we're looking for is the rate of change. How fast is the value of the computer changing as it ages? So again, we use m equals y2 minus y1 over x2 minus x1, and it looks like I did not take a picture of the calculator this time, probably because it was so easy. 18 minus 27 is -9. 3 minus 0 is 3. 9 divided by 3 is 3. -9 divided by +3 is -3. Well, that's correct, because our rate of change is decreasing. We call that depreciation. The cost is going down. The value is going down. Now we have to change this to hundreds. So -3 times 100 is -300. So the rate of change is -$300 per year. Or you could also say the value of the computer depreciates by $300 per year. You can always go backward on this video, which is in YouTube. You can always go back and re-watch anything over and over and over again. Now you've got to change gears. We're being asked about intercepts. They're very important. Intercepts are where the graph crosses the X and the Y axis. Here we have an equation of a line, this line, in standard form. Use the graphing tool to graph the line, so you'll be graphing this line. But how you graph the line is you have to find 2 points. And the 2 points you're going to be finding are the intercept. When you're looking for intercepts, you set up an X and a Y table like this. This line means, the top line means here, that X is 0, so what is Y? Down here, Y is 0, so what is X? And you have to calculate the answers. If X is 0, then X minus 3 equals Y is going to be 0 minus 3 equals Y. So -3 equals Y, and I put a -3 there. If Y is 0, I put a 0 in for Y. X minus 3 equals 0. I'll add 3 to both sides, and I discover that X is 3. So 0, -3 is the Y-intercept. 3, 0 is the X-intercept. 0, -3 is located here. 0, -3 with parentheses around it because you always do that with points. They're called ordered pairs. X always comes before Y, and you put them in parentheses. I know you know this, but I'm helping you remember. You might have slept. I do that on occasion. The x-intercept is 3, 0 right here. So that's how you'll graph the line. If it were me, I would graph the point 0, -3. I would click on it first, and then I would go to 3, 0 and click there, and then poof, my line would automatically appear. With a little practice, you can get really fast at this in my math lab. Now here's another line, a linear, well, it'll be a linear function. It would be in function form if we solved for y. Anyway, this is the equation in standard form. We're being asked to find the intercepts. Again, graph the intercepts, plot the intercepts in order to graph the line in my math lab. And I can help anybody who's never done it before. I also have videos for that, so I should upload those to Module 1 in Canvas. This video and the notes are in Module 1, Week 1 in Canvas. So we do it the same way. I set up this XY table. I put a 0 here. I put a 0 here. X equals 0. If X is 0, we find out that Y is 2. If Y is 0, we find out that X is 4. And then 0, 2 is the Y-intercept. 4, 0 is the X-intercept. And as you plot the points, my math lab is graphing the line automatically. Here's something completely new. Remember I said that this week I have peppered in a little bit of college algebra. This is another way to calculate slope. And you use this with functions that are not linear functions. Maybe they're quadratic, maybe they're cubic, maybe they're quartic, maybe they're fifth degree. But you can find the slope of sections of the graph. That is, you can find the rate of change by using this formula right here, which is called the difference quotient. Difference means subtraction. If you follow these 4 steps religiously, if I can use those words, that word, you won't get it wrong, you'll get it right. So I'm going to show you the steps. Here's our function f of x equals 4x minus 9. That's step 1. I write f of x equals 4x minus 9. Then step 2, I calculate what f of x plus h is. Whatever goes in these parentheses goes in for the x. So that gives me 4 times x plus h minus 9. I distribute the 4. That gives me 4x plus 4h equals 9. Now I have to calculate the numerator. What is f of x plus h minus f of x? That's step 3. We just found out that f of x plus h is 4x plus 4h minus 9. Minus f of x is 4x minus 9. That gives me 1, an invisible 1, times 4x plus 4h minus 9, which is 4x plus 4h minus 9 without parentheses. But this minus sign distributes to the positive 4x and the negative 9 in the parentheses. That gives me negative 4x, or minus 4x. Negative times negative is positive, plus 9. So I've got 4x plus 4h minus 9 minus 4x plus 9. I combine my like terms. 4x minus 4x minus 9 plus 9. What is 4x minus 4x? It's 0. What is minus 9 plus 9? It's 0. So I'm left with 4h. So f of x plus h minus f of x is 4h. Now I have found 4x plus h minus 4x, it's 4h. But the last step, step 4, is to divide by h. See, I'm finding everything in steps, so it's not all confusing if you go in steps. 4h over h will cause the h's to cancel, leaving me with 4. The rate of change of f of x equals 4x minus 9 is 4. The slope is 4. We would have already known that. Why? Why would I have already known that? Because f of x is y. This is just y equals 4x minus 9. And you know that when you have a y equals linear equation, you've got the number in front of the x is the slope. This is the difference quotient is the slope. Well, that's easy for a straight line. But what about this? I did this just to show you the steps. Now we're going to apply the steps to a nonlinear function, a quadratic function. Remember those? This is f of x equals x squared plus 4. And the instructions say construct and simplify the difference quotient. F of x plus h minus f of x over h. So we go in steps. Step 1, write f of x. F of x equals x squared plus h. Immediately underneath it, write f of x plus h. You have to calculate that. F of x plus h means you're going to put an x plus h in for the x. So you'll have x plus h squared. And then you've got a plus 4 at the end. This is a binomial. I should have told you something at the very beginning, and I forgot. So let me tell you here, and then I'll write it up there. H is a very small number. An example of H might be, this is an example. I don't know, they don't tell us what h is. An example of h might be 0.00001. That would be pretty typical. It might even be smaller, or it might be a little larger. You don't really want to write all those decimal places, do you? No, you don't. So we just write h. Now, x plus h is a binomial. When you square a binomial, you do this. Parentheses x plus h times parentheses x plus h. And you FOIL, or you distribute, whichever method you learned in high school or in intermediate algebra. Whichever method you use, you're going to get x squared plus xh plus xh plus h squared. And let me point out that there's an understood 1 in front of the xh and 1 in front of the xh, and there's even an understood 1 in front of the h squared and a 1 in front of the x squared. Isn't that fun? When you don't see a number in front of a variable, it's understood the variable is 1. So, back to work here. I combine like terms. 1xh plus 1xh is 2xh. Though I really should have written hx, shouldn't I? Because h is a variable, so I'm going to do that right now. No, I'm not. I can't. It's too late. All right, we'll just leave it. It's not a big deal. All right, x squared plus xh is 2xh plus h squared plus 4. That's what f of x plus h is. Let me write it over here. F of x plus h. Now we know what f of x plus h is and what f of x is. Now notice I came to my senses and I did change it here because I looked there and I looked here when I was doing this, and I thought, oh dear, h is a number. It belongs with 2. But it's not a big deal. F of x plus h minus f of x. This is f of x plus h, we just found it. X squared plus 2hx plus h squared plus 4. And let me point out that 2 times x times h is the same thing as 2 times h times x. It's just a matter of how you want to write it. So f of x plus h minus f of x. With an understood 1 in front of the parentheses, the 1 times x squared plus 2hx plus h squared plus 4 just gives me x squared plus 2hx plus h squared plus 4. But I have to distribute the minus sign to the positive x squared and to the positive 4. So that gives me minus x squared minus 4. This right here is what f of x plus h minus f of x equals. Now I combine my like terms. X squared minus x squared, that's 0. 4 minus 4, that's 0. So I'm left with 2hx plus h squared, and that's it. That's what I'm left with. Because this is 0, and this is 0, and 0 plus 0 is 0, right? So for that reason, these cancel out, goodbye. And we're left with 2hx plus h squared. That is what f of x plus h minus f of x equals. Finally, we're going to find the whole thing. First, we wrote down f of x, then we had to find f of x plus h. Then we had to subtract f of x plus h minus f of x. We found that. Now, we've got f of x plus h minus f of x over h. We just found out that f of x plus h minus f of x is 2hx plus h squared. And I'm going to divide by h, which means I divide each term by h. Notice that I wrote h squared as h times h, just to make canceling easier. Here the h's cancel, and so I'm left with 2x plus h. That is the rate of change for any value of x along anywhere in the graph, because x keeps changing. So I can find the average rate of change. And there's a way to find the immediate, the instantaneous rate of change as well, but you'll learn that in calculus.